So yeah, thanks very much for having me along today. So I want you to grab a piece of paper and a pen, because to start off with, I've got a question for you guys. So my question for you is, what do you think this is? Now feel free to write it down on your piece of paper, or if you're feeling particularly brave, you can put it into the chat. Totally up to you. Let me just click on this. So, and where do you think whatever this is found? So top left, we've got someone's teeth, someone's mouth. Underneath that, we've got a rock pool. Then under, we've got someone filling a glass with their tap water. And then underneath that, we've got, I must say, a pristine looking sewage treatment works. So where do you think this particular one is found? And where do you think it can be found in general? So that is my question for you. I'm going to give you just a sec. I have not seen many brave people yet in the chat, but the answer is, so this is a biofilm. So this is under SEM, scanning electron microscope. This is done by the University of Sheffield, actually. So yeah, this is a biofilm. So a biofilm is basically when microorganisms reproduce and they produce this sticky spider's web type material. And it's all sorts of nutrients as well as the microorganisms themselves, and they stick to all sorts of surfaces. So the actual answer is this can be found in all of those 4 environments. This particular example is actually from drinking water pipes. It's actually the 3rd one down. But the application that I'm going to be speaking with you about with this today is actually that final one, that sewage treatment works. So if actually an example of a biofilm is you brush your teeth at night and you're going to bed, you've not eaten anything all night long unless you're some sort of like sleep eater. And then next morning, you then have to brush your teeth again. And this biofilm is the reason why, because the microorganisms in your mouth when you're sleeping at night are reproducing and sort of forming this stuff. And that's why you've got to brush your teeth at night time and in the morning. But what has this got to do with the price of fish? So this is this biofilm, and that's what it is. And there's a really nice image there on the right-hand side done by Cat Fish from the University of Sheffield, all about what that biofilm actually consists of and what it is. But today I'm here talking to you about a sensor technology called SENTRY. So I've actually got one along with me here today. I can't see my own face on screen, so apologies if this is completely out of shot. This here looks a bit like a cheese grater. So what happens is you put this probe, this device, in water. So here as an example, we've got it in sewage. Now, microorganisms in sewage are really, really important because they break up all the sewage to eventually turn it back into water. So microorganisms are really, really important in sewage. But the thing is, if you put any probes, any devices, anything like that into sewage, as you can imagine, this biofilm, this growth forms over time. So for instance, if you've got like an ammonia probe, something like that, it's going to get growth over time, and you've got to take it out of the water, you've got to maintain it, you've got to clean it. Because it stops working and the signal doesn't start working anymore. But this device is actually designed for that biofilm to grow on it. That's the purpose of it. So what that means is that you're not taking it out of the sewage and you're not cleaning it, you're not maintaining it, you're just putting it in and just letting all of that biofilm grow. And that's exactly what it's designed to do. So that's SENTRY and how it sort of links into this biofilm and those microorganisms. So what the SENTRY device actually does is normally these microorganisms, when they respire, so when they sort of breathe, they give off electrons into the environment. But what the SENTRY unit does is it actually captures all of these electrons and it counts them. So in that way, it's able to count the number of microorganisms, the microbial abundance in wherever you're putting it in. So in that sewage process, in the treatment train, wherever that might be, you're able to get a feel of the microbial abundance, and we're directly counting the respiration rate of those microorganisms that are there. So with the SENTRY unit, what we're trying to do is we're trying to build up a richer picture of what microbiology is doing in water environments. Because at the moment, water companies, they monitor things like I don't know, for instance, ammonia, pH, phosphate. But at the end of the day, all of these are sort of precursors for how microorganisms might be reacting in the sewage, because it's really important to have healthy microbial growth if you want your sewage to be digested. So with SENTRY, we're trying to work out what's going on in greater detail within sewage treatment works. So I'm working with a couple of case studies right now, and I'm doing a lot of data analysis, if I'm being honest, right now. But one of the case study companies that I'm working with, one of the sites I'm working with right now, the real focus there is on compliance. So what happens is the sewage treatment works, they not only take on sort of waste from people's domestic toilets, but they can also take on waste from things like factories, trades. So you've got a lot of trade effluent going in there. So a really good example of this is over lockdown, when lockdown first happened, a lot of breweries suddenly had a lot of beer that couldn't be drunk by people, and really sad loss here. Really, unfortunately, it had to get tipped down the drain. Now, companies like Anglian Water allowed this to happen, so normally it's very strictly monitored, but in this case, there wasn't really all that much they could do, so it was allowed. So you had these companies putting this beer down the drain, and it really impacted the microorganisms of these systems, because beer is very microbial active anyway. You know, you've got yeast and things in there. So it was really having an impact on the sewer networks and on the treatment works themselves. But what SENTRY can do is act as an early warning system for these loads, for these variable loads that can happen. So if you have one at the beginning of the works and you have one on the end of the works, you can kind of see like, oh, this is what's coming in, but we're dealing with it. It's okay. And alternatively, you can say, oh my God, this is coming in. We need to do something about this. This is of concern. So an example for you about this. So this is what the platform, the dashboard looks like for SENTRY itself. So I've circled in green here examples of toxic shock events. So what this basically means, you can see the blue line. So those are the microorganisms, the respiration rate of those organisms. It's perfectly steady, and then there's a sudden drop. So what would have happened then is maybe you've got a company like, I don't know, just as an example, like Coca-Cola or like a paper manufacturing company, and they've put something down the drain that is then killing off these microorganisms in the treatment works that are supposed to be there to help digest the sewage. So that's a big problem there. But the works, they'll know about it, the operators would know about it, because this SENTRY device is saying, look, this is going on. And another case study that I'm working with a different company right now is a piece all around energy optimization. So I know water companies at the moment have got this driver to net zero energy, particularly in wastewater. And it's really making companies like think about their practices, like, how can we make this better? How can we improve this even more? So how this is working is it's a bit like street lights that are motion sensor. So you're walking along and the light comes on, and then you walk by, you're past the lamp, so the lamp turns off to save energy. It's pretty much the same situation. So with SENTRY, when the microbial load coming in is low, parts of the plant can be turned off to save energy. So at the site that I've been doing this with, crunching those numbers with, we were doing this particularly on the bath units. So we had one sensor before the bath and one sensor after the bath, and they had 6 bath units. So the plan was that when microbial loads are low, 2 of the 6 would be turned off to save a bit of energy. So I actually found that this would be a 10 to 20% energy saving for that particular site, which for that site would result in savings of £50,000 to £100,000 a year by having this in place, and just really understanding what loads you've got coming in. If you're dealing with it, you can adapt the plant to suit these loads. So where are our trials happening so far? So we've got 2 over at Anglian Water. So one of them is a really small sewage treatment works where there's no one based on site. So this is really helpful for those guys, because they can get an indicator of what's happening at that works without actually having to go in person. And we've got another one that's about to go in Anglian, which is part of a wider project and lots of different sensor technologies to sort of compare and contrast the data between the different devices. Wessex Water, we've got one looking at that energy optimization type of thing. Hopefully I'm going to be doing a few articles and that kind of thing in the Institute of Water magazine around that and how that's sort of progressing. We've got quite a few over at United Utilities right now. That's going quite well. There's a lot of interest comparing flow to microbial flow. So if you're operating your plant just by flow, you might see lots and lots of events, but actually some of them, it might just be stormwater. It might be a lot of flow, but not a lot of microorganisms. So it's sort of differentiating between those really. And Scottish Water, we're hoping to have one set up sort of in the next few months. With Scottish, we're really interested in, they've got a lot of sensors already, sort of looking at the chemistry of site and things like ammonia, pH, conductivity, that kind of thing. But they're really missing that biology like side of things to work out, you know, more broadly what's going on in the site. So we're going to be doing a trial with them to look into that. So a few different trials at the moment and a few different companies, but ideally I'd like to see some more permanent installs, maybe some more in these different companies, and maybe some different companies as well. But that's where we're at with our trials that we're running at the moment. So for me with SENTRY, I think the biggest advantages to me that I find about it is that proactive management. So it's allowing water companies to be able to respond before compliance problems happen and that kind of thing. So it's about reacting proactively rather than reactively. Secondly, the data output. So you can have use the dashboard that I showed you before with that toxic shock event, or it has full integration into SCADA. So whichever works best for you really. In future with that data output, ideally I'd really like some form of automation. We're not quite there yet, but at the moment how it works is, for instance, with the energy optimization piece, you know, an operator will get an email or they'll get a text telling them that the microbial load is low, so that they can then turn the blowers off. But in future, I'd really like that to be an automatic process. But when we're not there yet, we need a lot more data, and also we need a lot of historic data. We need these trials to be running for a long period of time, so that we can sort of understand how seasonality impacts things, and to have that background historic understanding of these sites, because every site is different. Their loads coming in is really different. So we really need to categorize what is normal for that specific site. And then the final advantage is that it's sort of online and no maintenance. So when I say sort of no maintenance or zero maintenance, I spoke earlier about that ammonia probe and how you have to take it out and clean it. This isn't the case with this probe because it's designed for those microorganisms to grow on it. So for instance, we've got a SENTRY unit over at United Utilities. That's actually been in place for 2 years now, no cleaning whatsoever. And I think both of these two things combined has really made a difference during sort of COVID times. So operators are allowed that they can see what's going on at that site from when they're working from home or wherever they've got access to the internet. You know, that you don't have to do a site visit, you don't have to go and take some grab samples to work out what's going on. Reduces sort of the difficulties for the labs, because the labs have been running at lower capacity, so it's more difficult for them to be analysing the samples because they've got a distance and so on. So I really, you know, there's been a real advantage of this new like online way of working during times of lockdown and coronavirus. So that's been me. I've been Natalie Lamb here today talking to you from QCL, and here's some of our wider team. So we've got Tom and we've got Patrick as well, and Patrick is CEO of SENTRY. So you might have seen some of these faces talking about this item, this device. So my presentation today has been called Real Time, so 1 reading a minute, microbial performance monitoring, basically just counting the numbers of microorganisms in wastewater treatment systems, so in sewage. So thank you very much for listening to me today. Feel free to email me if you're interested, or give me a call, contact me on LinkedIn or Twitter. Just get in touch if you want to find out more. Thanks very much for listening.